The number of bacteria in a culture after a number of days from the start of growth is displayed in the table below. Plot the points on the grid below. So we've got 1, 5,000, 2, 9,000, 3, 13,000, 4, 17,000, and 5, 21,000. Do the points form a straight line? Well, the answer to that appears to be yes. We don't put an arrow on this end because there's no time before 0. If growth continues in this way, how many bacteria will there be after 6 days? Well, we could just extend the table. It seems that every time we go up 1 day, we go up by 4,000. So that seems to be 25,000. And then we could just continue on to get to 10 days. So at 7, it would be 29,000. At 8, it would be 33,000. At 9, it would be 37,000. And so at 10, it would be 41,000. Why is it unrealistic for growth to continue like this? Well, sooner or later, they're going to run out of nutrients and so on. And so it can't just keep growing forever. If you think about it, if it kept growing forever like this, eventually this bacterial colony would be the whole universe. Can you find an equation that describes this line of the form n equals AD plus B? We've seen this form in a few other examples. Well, when the days are 0, n would be equal to b. And we can see just here that this is 1,000. So I think we've got something that goes AD plus 1,000. Because then, when d is 0, n equals 1,000. And we can see that both from our graph and if we went back 1 day on the table. Now, if we look at the graph or the table, this is when d is 1, and we've got that n is equal to 5,000. So, if we substitute those in here, n is 5,000, d is 1, that must mean that a is 4,000. So we could try n is equal to 4,000d plus 1,000. Does that work with another point? Such as here we had the point 4, 17,000. So substitute in d equals 4 and we get 4,000 times 4 plus 1,000, and that is equal to 17,000. So it seems that this would be a good equation.